Hi everyone, and welcome to Jam Academy. In this example, a force given by 10I plus j minus 4k newtons acts on a particle that undergoes a displacement from r equal to 3I plus 6j to r equal to 5I minus 5k meters. We've been asked to calculate the work done by the force on the particle and the angle between the force and the displacement of the particle. This is quite a beautiful problem. Now, the work done, this is actually a two-dimensional problem. So the work done, W, by a force F, is just the dot product of the force and the displacement. The force itself is given by 10I plus j minus 4k. Now, the displacement of the particle is just the final position minus the initial position. When you are adding or subtracting vectors, you only add and subtract the corresponding components. Let me say that again. When you are adding or subtracting vectors, you add and subtract the corresponding components. So this is our final, and this is our initial. So 5I minus 3I, that will give us 2I. Remember, it's 5I minus 3k, which means that the j component is 0. So 0 minus 6. So this is negative 6j. Now you have negative 3k minus 0. This will give us negative 3k. This is the displacement of the particle. Now also bear with me that if you have a vector A given by AXI plus AYJ plus AZK and another vector B given by BXI plus BYJ plus BZK, then A dot with B is equal to AX BX plus AY BY plus AZ BZ. This is the formula that will help us to calculate the dot product between two vectors. Similarly, A dot B will be equal to AB cosine of theta. So always remember these two formulas. That being said, this would mean that the work done by the force on the particle is given by, you simply multiply corresponding indices. This is 20 minus 6 plus 4 times 3, that gives us 12. So this will be equal to 20 minus 6, that gives us 14. 14 plus 12, that gives us 26 joules. So the work done by F on the particle is 26 joules. The next part of the question, which is really important, is to calculate the angle between the force F and the displacement vector. So cosine of theta is equal to A dot B divided by AB. Remember, A and B are the magnitudes of vector A and the magnitudes of vector B. In that case, we know that F dot dr is equal to 26 joules. That's what we know. So the magnitude of F, which is just F, is equal to the square root. We use the Pythagorean theorem. This is going to be 10 squared plus 1 squared plus negative 4 squared. Now similarly, the magnitude of delta R is the square root of 2 squared plus negative 6 squared plus negative 3 squared. If you calculate this, 4 squared is 16 plus 1, 17. 17 plus 100, this will give us 4 squared is 16, 17, this will give us 117 newtons. And this will be 4, this is 4, 36, 9, this is 40, and you will have here the square root of 49 meters. So what we have here is the cosine of theta will be equal to 26 divided by the square root of 117 multiplied by the square root of 49. And from here, you can calculate the angle theta by using inverse cosine. Now do the calculations and you'll put in your answer in the question box right below this video as a homework. Thank you so much for your time. Please, I sincerely mean this. If you have difficulties understanding these concepts, do not hesitate to ask, participate in the discussion forum below every video that is posted in this course. Thank you so much and remain blessed. Bye-bye.